Good morning there, friends. Welcome. This is July 9th, 2021. One thing 4D Solutions does is sponsors, along with co-sponsors, something called Oregon Curriculum Network. And here in the state of Oregon, where I've lived for many years, actually started out here in the 50s, coming here from Chicago as a very young, like infant toddler, and living here in Portland. Then we left the country and I came back to Portland in the mid 80s. And I've been here pretty much ever since, based here. And my daughters went through Portland Public Schools. We've had a lot of experience with school systems, collectively, individually. And it's part of my background to have taught in a high school, right? Full time. More recently, part time. More recently, I've been popping up around Portland in a company called Coding with Kids. I did that for quite a while. I also bill in the sense of promote, like putting on the marquee, putting on the bill, that this is Quaker influenced. Hence, partly the symbolism of the hat. You see I'm wearing it over there as well. Now, what this video is about is what I've come up with as a canonical lesson plan, we could say, an introduction or signature lesson that you as teachers can use to signify that your school is shifting into this particular lineage or current or flow of ideas that we can trace rather specifically. And I'm going to end the video with some of the intellectual pedigree here. Obviously, there's the Buckminster Fuller, that goes without saying almost, but I always say it. And indeed, what this canonical lesson plan is about is, of course, his odd approach or different approach, but signature approach to A, the concept of dimension, and B, the concept of mensuration, i.e. measuring, i.e. what is the volume of X, Y, or Z. We could say polyhedrons, but everything's polyhedral. If you're a container of any kind, you can be modeled, and therefore you're a polyhedron, we could say. So polyhedrons are not obscure. They're not like, I've never seen one, or only in school do we see polyhedrons. No, you are a polyhedron. You're a walking, talking, breathing polyhedron. Now, this is a slideshow that I've made public and encouraged people to download and use as a backdrop for their own talk, or excerpt slides, which has been done. People have even come on wearing a hat, right, like mine, to show they're on board. But use the whole slideshow if you want. The slide I'm focused on right at this minute has to do with, okay, we pack spheres in what's called the CCP. This is generic math talk, and college level usually, though, we don't usually let high schoolers waste a lot of time with sphere packing and the formulas that go with it. Now, I say waste a lot of time sarcastically. Ooh, I dropped two of those. I got to get those. Can't let that entropy go for too long. And we have the rhombic dodecahedron around each one of those balls in the CCP. So the line that communicates between one ball center and a neighboring ball center is through the diamond centers. And this all is like very, very basic to our curriculum. This kind of thing that I'm telling you right now, it's like, gosh, of course you know that. Of course you know that. But we're still going further. I mean, that's not the end of what to know. And this is kind of a generic curriculum. So I'm going to be talking politics, sociology, history, anthropology, and the STEM subjects. And there's a CP Snow Bridge, we call it, between STEM and the humanities, which actually the sphere packing stuff that we're doing is how the bridge is made. You could say the bridge is made out of a lattice of closest packed spheres. That's all metaphorical. It's figurative language because we're coming from the humanities originally, being human and all that. So I've got stuff on logarithms and bases. This is not Common Core. This is not new math, and this is not new math. This is a lot of really old math. We've got Gauss in here. We're bringing back number theory a lot more. But the canonical lesson plan I'm talking about starts with the quadray coordinates. Now, I was still scrolling back in my slideshow to this one. Any four CCP balls, that does not mean Chinese Communist Party in this namespace. CCP is cubic closest packing. And it is the closest packing. They've proved it mathematically. But there are other sphere packings with different names of equal density that are, you could call it the CCP family. There's HCP. J.H. Conway taught me Barlow, Barlow packing was his term for it. Barlow being a serious crystallographer. And crystallography is all into CCP, they know it. And the tetrahedron can come out of it. You pack any four spheres together, and there's your beginning tetrahedron, right? Of volume 1 in synergetics. And what we're saying in this lesson plan is that if you do a random walk with 4 random walkers all starting at the origin, and every turn to play, they have to pick one of 12 neighbors, i.e. a sphere center, 12 around 1, a neighboring sphere center. So at the corners of a cube octahedron, we have the neighboring spheres touching the one we're at. So say, buried down in the middle of this tetrahedron, this yellow ball, although it's not here depicted as intertangent with its neighbors, it's actually suspended by struts relative thereto. Were they touching, I could say this was the CCP, and I could jump, say, and I still, even here I could take the train or whatever, to get to a neighboring sphere, to one of the 12 that's immediately adjacent to me, is how it works. And this sphere packing, again, is the CCP. It's very critical to, there it is again, here it is growing and expanding. This is what connects us to STEM in a lot of ways, are these counting patterns. How many spheres in each layer in this growing cube octahedron? And this is our doorway, you could say, into spatial thinking, and it's not XYZ. And we've got those 4 random walkers who take off from the common center, and at every turn they have 12 balls to jump to. And we do that for a while. We give them like 1,000 hops or how many we want. And we stop, and then we connect the 4 vertices so formed. Now, we wouldn't expect them to be coplanar with all that randomness, but should they be, there's no real volume there. It's a 0 volume. It'd be fun to find that, but it's going to be a whole number volume. And digging up the proof, you know, a lot of this stuff is getting lost because no one's teaching it and so on. So whether Bob Gray can find his proof or not, I don't know. But we can study this empirically, and we can use, I think it's intuitive, actually. We'll talk about it another time. There's a lot that we could use help on here. Like, we're blazing this trail because it's important to do so because of the futurism attached to all this, and the rationality, and the fact that it's something to see as part of your heritage. Like, this was a very important futurist, and the U.S. hung its hat on his work a lot, like at Expo Montreal and Afghanistan, Kabul, Bucky's geodesic dome. His architecture was a showcase of, quote, American progress, American civilization. And Fuller took that on. He was willing to be used in that way. He encouraged it. He was that. And then after he died, his key information, decisions were made. Basically that we don't need any canonical lesson plans dealing with this kind of stuff. So you have had 2-3 generations with pretty much 0 exposure to this important philosophy. So we're fixing that. I was going to say rectifying, kind of tongue in cheek. And we're connecting it to mainstream philosophy through such as Richard Rorty, who was my teacher at Princeton. He wrote this book called Achieving Our Country. You could call it patriotic, but not in a dummy kind of just flag wavy kind of way, right? He sees a lot to respect and honor, especially in the struggle to, you know, move towards something ideal. And he fingers German idealism, as a lot of thinkers do, as super influential on American philosophy. And of course, one of the branches of Hegelianism, you could call it, is Marxism. But what Rorty is arguing is if you're talking anti-imperialism and a vision of the country where it's not a global tyranny, you could call that a left-wing leaning. There's no need to trace through Marxism as your lineage if you are wanting to embrace sort of idealism that you'll find in, say, German language philosophy. So you go to Rorty, he had coined the term linguistic turn, and he's incorporated into pragmatism, which you could see as a successor in many directions from American transcendentalism, goes to pragmatism. You can find he's incorporated a lot of Wittgenstein into pragmatism in terms of non-representational functions of language and so on. So that's a bigger sort of humanities side, what the context is, but the canonical lesson plan I'm talking about, you don't need to get into all that philosophy right then and there. Just showing you that since the year 2000, Oregon Curriculum Network has been publishing world readable format for all teachers everywhere, this kind of information, you know, linking closely, there's our 12 choices to surrounding balls, linking closely to computer programming, because the belief over here is you teach coding and math concepts in tandem, along with the old typography. So when we're doing, say, logarithms or whatever, we have handy a computer language, and we can show very clearly through computation how these concepts, complex numbers, logs, everything you learned in high school is going to be here in the STEM. Like our STEM is going to be pretty strong. It's going to have a lot more number theory in it, and this vector algebra called quadrays, which I call syntactic sugar, bolted atop XYZ, is going to really give them fast fluency in the Bucky stuff. And that's what the cutting edge is here, because we need a futurism to motivate the remote campuses, the network of remote campuses, the prototype testing of, quote, refugee houses. We're all refugees. We're all faculty students on Spaceship Earth equals Global University, right? You've seen my Martian math interviews and stuff like that. You understand the shop talk over here if you watch this channel. For example, by Martian math, I'm talking about one of 4 math categories in digital mathematics at this Silicon Forest website. Actually, I think the servers are in New Zealand, but again, Oregon Curriculum Network, Silicon Forest, I point to it right here, Doug Strain et al., lots of stories, Tektronix and so forth, has no direct spokesperson. In other words, I'm not appointed by some committee to step forward and represent the Silicon Forest, no, but I am a, you could say a digital native of, and think a lot the way people do in the Pacific Northwest. So it's cultural. What I'm passing on is a Pacific Northwest contribution to math education, STEM side. And on the humanities side, if you were following any of that, left versus right and so forth, that's what I call the struggle to create USAOS, operating system. OS for operating system. And it is global in scope, but not tyrannical, because we recognize that any mature nation is going to have the globe, which is a small little ball, in focus as what needs to be managed. It's not stupid to think globally, and it's not necessarily imperialist to think globally. This whole idea of think globally, act locally, again, coined by Bucky Fuller in some accounts, right? That's a controversy that we experience today in the form of globalism versus nationalism. And I don't want to avoid that kind of debate. That's where we need to dive because it's so clearly cut out for it. It's like we have exactly the precise framework one needs to gain traction in some kind of debating format, which I encourage, right? I'm all for debate, as is Rorty. So finally, I'm saying in one of the transcendentalist groups here on Facebook, I've got one of my comments here. I'm going to summarize the humanities side. CP Snow Bridge, back to the humanities, sphere packing our bridge construct strategy. The anti-imperialists I follow, as well as lead, have roots in American transcendentalism, which traces back through Harvard especially. So here we're getting to the time of Emerson and Margaret Fuller, Fuller's great aunt, to German idealism. Walt Whitman studied Hegel. Roll forward through pragmatism to Rorty, who wrote Achieving Our Country. It's what we've been talking about this same ambivalence. The ambivalence is America a democracy or an empire? And this ambivalence traces back to the story of Rome, of ancient Rome, and we got to keep that in focus. From this point of view, Marxism was a detour. We are much more interested in the futurism of Buckminster Fuller and the fact that he declared the USA we have known bankrupt and extinct in the 1980s. So back when Ronald Reagan was president, he was awarded the Medal of Freedom. At the same time, Grunch of Giants was coming out, which was basically declaring the nation-state system as we know it too eroded to be recovered. And I think we've seen since then, in the intervening time, continued erosion, right? A new world order is always emerging. People get paranoid about that. They think because there's some specific world order that's being imposed. But I'm just saying the new is always coming. There's always ferment and change in the winds, right? And his long-term arc is that we won't be having the same idea of nations as we do, but we'll still, have all the history that we have. Inertia is not negligible. You can't not notice that people have fought and died for X, right? You still have to go back and understand all that. So by X, I mean put in what you want to put in there. So there's this whole history here. I take heart in the fact that most Americans don't know their history. Like, who knows what I'm telling you? How many people go to high school and even learn about tetravolumes, measuring volume in how did this get to be volume 6 in my account? And how did this get to be volume 1? And remember the relationship, it's the long diagonal of the that's just held together with magnets. The rhombic dodecahedron there, the long diagonals thereof are the same as the diameter of our unit spheres. In other words, there's a unit sphere inside each one of these rhombic dodecahedra, and if you zoom back, it looks kind of like this. Now, do you learn much of that? And do you learn to give whole number volumes to any of those in your schools? Not at all. There's a decision's been made to not let you in on this kind of heritage. And my schools and schools that want to fight that decision have an easy way to sort of show the world that they're doing that. They simply need to start teaching some canonical lessons, such as we are doing right here. And I'm sharing the wealth. All right. Teachers, good luck. Send me your feedback. I'm going to be testing some of this material. I'll be testing probably the logarithms material this evening. with my students. Quadrays, I always talk about them, but briefly I talk about vectors in general. I circle around everything, but what night, what evening, what session we actually dive deep on X, Y, or Z, that depends. We haven't looked at complex numbers yet. So this is a particular session I'm talking about. I prototype this curriculum with actual students every so often, and I'm in the middle of one of those prototypes sessions right at this moment. So I'm reinventing a lot of it again, doing it all again. Because as you've seen, this random walk stuff I've been doing for a long time. Oregon Curriculum Network has a long history of dealing with this stuff. Here we go. This page here is from 2000, remember. And we've got Pascal's triangle front and center as usual. And the approximation to it of the normal curve as we get to data science. There's your bridge. So yeah, I've taught the data science too. Good stuff here. Recommend you explore. You'll get a lot of your heritage back. All right. Talk to you soon.